Hello guys, welcome back to another episode of Codergirl.py. My name is Serenity, aka Codergirl. This is my friend Scooter. Today I'm going to introduce you to debugging your programs using Python. Hope you enjoy! Alright, so today I'm going to cover the debugging process, which is where programmers find and correct errors in their program. We have a lot to cover today, so let's get started. Alright, so in my IDE, I have one new folder, debug. In my debug folder, I have three new files, error.py, error1.py, and tips.txt. Let's open up error.py first. So in error.py, we try to compare an inputted username to a set username, Codergirl.py. You can see that I declare a variable called myUsername and assign it to the string Codergirl.py. Then I create a variable called enterUsername and I assign it to the input function where the prompt is enterUsername. Finally, I use an if statement to compare the variable myUsername to the entered username. If myUsername is equal to the entered username, I print out logged in. Else, I print out incorrect username. Now you might already see the error in this program, but let's run this. Let's run this program by clicking the run button up top to just see what the output is. When I click the run button up top, you can see I get an error. Syntax error. Invalid syntax. Now, if you've tried the examples in my Codergirl videos, you might have gotten errors similar to this. And these errors might seem technical or cryptic, but they're actually very important and they're a big part in programming. So let's kind of break this error down. You can see the first thing, it says file, and then it shows the path to the file that I'm working in. So home, Ubuntu, workspace, debug, error.py. Next, it tells me the line that the error occurred in, line 7. It then shows me the actual line if my username equals entered username. You can see that it has a symbol pointing to our equal sign in the if statement. That tells us that the error originated from that equal sign. Finally, it tells us what type of error we got. We got an syntax error, so invalid syntax. You can see that this error is really simple and really straightforward. It's very helpful as well, since it tells us what file we're working in, where the error occurred, what type of error it is, and what part of our line the error occurred in. And based off of this error, I know that the error had to occur in my file, error.py, at line 7, and it has something to do with my equal sign. Now that I have all that information, I can go back to error.py. And when I take a second look at this program, I can see what's wrong with it. In my if statement, I'm using one equal sign. However, in Python, one equal sign is used to assign something to something else. For example, to assign a variable to a string or other words. However, if I want to compare two things, like if I want to compare something in an if statement, I have to use two equal signs instead of one. And before I fix this error by adding another equal sign, you can see that there's a really cool feature in Cloud 9. On the side, you can see this little red symbol. And if I hover over it, you can see it shows invalid syntax. So I didn't even have to run this program to know that there was an error in it. And it doesn't tell us where the error originated, so it doesn't tell us that it's in the equal sign. But it does show us that it occurred at line 7. So I could have probably figured out this error without even running it. So now that I know what the error is, that I'm not using the right amount of equal signs, I can fix it by just adding another equal sign. Now that you can see that when I fix the error by adding another equal sign, and I save my new file by clicking Save, and then when I run the program by clicking the Run button up top, you can see that that error is gone and our program runs as it should. Perfect. Now that you know that errors are really helpful, you can now kind of use them to figure out problems in your program. However, not all errors in programming are errors that you get in the terminal or console. Some of the errors in programming are errors with the result of the program, not with the syntax. So I have an example in error1.py. So let's exit error.py and head into error1.py. In this program, we're trying to multiply an inputted number by 5. And this program is an example of how sometimes errors aren't errors in the terminal, but rather errors with the result of our program. So in error1.py, you can see that I declare a variable called number, and I assign it to the function input, where the prompt is enter a number. Then I declare a variable called equation, and it's equal to number times 5. Finally, I use a print statement to print out the combination of number times 5 equals and stir equation. So let's run this program to see just what happens. I'm going to run it by clicking the Run button up top. And you can see that we don't get an error in the terminal, so we know there's nothing wrong with my syntax. At the prompt, enter a number, I'm going to enter the number 5. Now when I hit enter, I expect to see 5 times 5 equals 25. However, I see something different. I see 5 times 5 equals 5, 5, 5, 5, 5. 5 5s, not 25. So that is an error with the result of my program. Now, this is going to be a little trickier to fix since I don't have an error in the console telling me where the error is occurring and what it originated from. So I'm going to have to figure it out on my own. When I head back to error1.py, you can see that it's a relatively short program. So one thing that I could do is try to figure out where the error is occurring. And I can use that through the elimination process. So let's think about this. I know my print statement worked since it printed out the number, the string times 5 equals, and then it printed out the result of our equation. So I know that the error doesn't have to do with my print statement. Now let's look back at number equals input, enter number, and the line equation equals number times 5. I know that the error has to have something to do with here, but I'll have to eliminate one of these lines of code to actually see where the error is occurring. I can do this by substituting parts of the lines of code to try to eliminate it. Let's take a look at equation equals number times 5. Let's say I want to see if equation is working correctly. I can substitute the variable number with a set number. So let's say I can take this out, number, and replace it with the number 4. 4 times 5 is 20, so I should expect that the result of the equation should be equal to the number 20. And before I run this, to remove any confusion, I'm going to replace this number in my print statement with the string 4, just so I know what I'm actually doing, that I've replaced the placeholder number with the set integer 4. So I expect this program to return 4 times 5 equals 20. Let's see if it actually happens. I'm going to run this program, you can see it says enter a number. Because I'm not actually using number in my equation or print statement anymore, I can just hit enter. You can see that it now prints out 4 times 5 equals 20. Remember that instead of using our placeholder number for the variable number, I replaced it with the integer 4. 4 times 5 is in fact 20, so we know that my equation is working correctly. By using this sort of elimination process, I've narrowed it down to just one line of code where the error could happen. Number equals input, enter number. Before I continue though, let's make sure that I swap out 4 back for number, just to make sure that I'm being consistent. So let's exit number, or let's remove 4, and replace it and restore it to the original values, number. Save my file. Now I've narrowed it down to line 5 in our program. Number equals input, enter number. When I look at this line, I don't see anything immediately wrong with it. How am I supposed to tell whether a number is actually doing what I want it to? How can I see what the value of number is? How can I see what the type of number is? Luckily, in Python, there's a function called type that allows me to see the type of data that I have. So, for example, in the type function, if I use type with the integer 5, as you can see right here, that will return class int. Don't focus on the class part right now, since that's something that we haven't learned yet. Just focus on the int part. This int tells us that the data that we used with the function type is in fact an integer. Type with the string ABC returns class str, telling us that the data we used with type is a string. Type 4.5 returns class bool, telling us that it's a boolean. Type 4.5 returns class float, telling us that 4.5 is a float. Type true returns class bool, telling us that true is a boolean. Finally, type used with a list to the string a in 4.5 returns class list, telling us that it's an array or a list. Now that I know that type can tell me what type of data I'm dealing with, I can use it with our variable number to kind of see if I'm getting it the way I expect it to see if number is actually an integer. So I can use type in a print statement, print type, and then use the value number instead of an integer or something. This will print out the type of data that number is. So let's save this file and run it. You can see it says enter number. I'll enter the number 6. You can see that it returns class str. So that means that number actually isn't an integer. We're dealing with a string. Armed with that knowledge, let's head back to error1.py. When I look at my program, it makes sense. Input is a function that returns whatever the user entered as a string. So that means that number is actually being stored as a string, no matter if the user enters 5, 4.5, or true. To fix this, I can use the functions that we learned in our previous episode, int, str, bool, list, etc., to turn number into an integer. Now I can remove my print statement, since we already know what type of data we're dealing with. And now it's just a matter of where do I put this function? What would be the most efficient? There are two different places I can put it. First, I could use int around the actual function input itself. That way, if I want to make other equations or work with number a little bit more, I don't have to remember or keep putting the function int in front of it. However, that would mean that I have to put the function str in our print statement to make sure that I can combine it with another string. In our equation, I could use int there for int number times 5 That way I don't have to worry about putting stir in the print statement. So I'll put it in our equation, int number times 5. Now, this will return the integer form of number. So whatever the user enters, if it's a number, will be converted into an integer. So now this should work. One quick note here is that if the user enters something that is not an integer, let's say they enter ABC or 1, 2, 3, or true, this will not work. The program will return an error. And I can get past that by adding in an if statement to check if the type of number is a stir, or I could get past that in a lot of ways. But for right now, since I know what I'm going to be entering, I don't need to do that. So let's save this file and run this program one last time, just to see if we finally figured out what it's doing. Enter number, I'll enter 5. We expect this program to return 25, since 5 times 5 is 25. Let's see if that actually happens. You can see that it prints out 5 times 5 equals 25, just like we expected. Now that you know that errors with our program can also mean errors with the result of our program. And we have to use more creative ways to solve the error and fix it. You can see that we use the process of elimination, and we use the function type to narrow down where the error is occurring, and finally fix it. One last thing to cover is in tips.txt. Exit out of error.py, let's exit out of the terminal, and open up tips.txt. In tips.txt, you can see it is simply a text file, so no code here. There are some ways to make the debugging process easier. For example, you can use descriptive variable names. Let's head back to error.py to show an example of that. Let's say I named number something that wasn't actually correct. Let's say I named number, let's say string of ABC. That isn't actually what number stands for. Number is supposed to be an integer that the user entered. But string of ABC can be misleading to you or somebody else reviewing your program, since we're naming it something that it actually isn't. Another thing might be if I named number M and I named our equation N. These aren't descriptive, and these two variable names are very similar, so it can lead to confusion later on. For example, accidentally using N when you mean to use M. So it's better to stick with descriptive variable names, such as number and equation. Another tip is commenting throughout your program. Even though it might seem little, commenting throughout your program can help you keep track of what you're doing, what each variable stands for, and what the goal of the program is. It also helps to separate your code into chunks that makes it easier to debug it. We can also start out with the first error. Sometimes one error in a program can lead to multiple, so fixing the first error might fix all of the other errors that you get. Pretty cool, right? Another tip is to avoid getting frustrated. As hard as debugging is, and as frustrating as it may be, getting frustrated will only cloud your judgment and may prevent you from seeing some obvious mistakes in your program. So even if it means that you need to take a little bit to cool off and clear your head, it will make debugging so much easier and so much faster. The final tip is to create pseudocode before your program. You can think of pseudocode like the English version or the English translation of your code. For example, if my code was if x equals y, x, or number equals x divided by y, that is actual Python code. Pseudocode would be the English equivalent. So if the variable x is equal to the variable y, create a variable equal to x divided by y. You can see that instead of writing what I wanted to do in actual Python code, I wrote it in English code, or in English. This makes it so much easier to see what the goal of your program is and what you want to do with your program. And it also makes it a lot easier if you don't know where to start on a program. The more you code, the easier it'll be to translate that pseudocode into actual Python code. In addition to all of these helpful tips that I have, there are multiple online forums where you can ask for help if there is an error that you simply do not get. Forums include Stack Overflow and Reddit. I've asked some questions on Stack Overflow for simple errors that I don't understand. If you want to see an example of some of my questions, you can look up the user Supernova Coder, which is my username, and you can see some of the questions that I've posted. So it should be very helpful. Now that you know the tips about debugging, it should hopefully make it easier. However frustrating debugging might be, it's an important component to programming, and it's good that you know how to deal with it early on. I hope you enjoyed this video. If you did, please leave a like and subscribe, and I will catch you guys later. This is Codergirl.py signing out.